get x, we get y, we get n is 8. And we know that k has the possibility to be 0 to 8. We agree? 0 all the way to n every single time. So if you're like, it's 4, okay, it's possible. It's 9, it's not possible, right? Okay, so let's fill in what we do know. And please always put that plus minus sign in there, okay? Make sure that your y is negative if there's that subtraction sign in there, because they'll have the answer to y being positive and you not putting that. All right, let's fill in our formula. Tk plus 1. I don't know the term, so I have to put a k for now. Equals 8 c k. X is 5 to the 8 minus k. And then y is negative 2y to the 8. Sorry, to the k. I don't know why I said 8. Now let's reread the question. The term with the y5, y to the power 5, in 5 minus 2y to the 8 is. Anyone have any hints as to what k would have to be in order to get y to the 5? It would have to be 5, right? Because this here would distribute to that y to the 1, so it needs to be a 5 in order to get y to the 5. We agree? So let's fill it in. T5 plus 1 equals 8c5, 5 to the 8 minus 5, negative 2y to the 5. So it's term 6. Does anyone know what 8c5 is? I think it's 56. Yeah? Here's the G. 56. And then 5 to the 3 is 125. And then we have to remember to distribute the 5 into the negative 2 and the y. And if you're somebody who didn't do the negative 2 again, start, remind yourself. So it's negative 2 to the 5 is negative 32. Y to the 5. So T6 equals what? Negative a large number. Does anyone have the number?
Negative 224,000.
Did everyone get that? 224? Okay. Paying attention. It asks for the term with y to the 5. So you would box this, because this is the term. And that is correct. Little caveat. What if they asked you instead not for the term, but they asked you for the term number? What would your answer be? Right? Very different questions. And I believe in your hand in, I do ask for a term number at some point for one of the questions. I want the term number. I don't want the term. Or people will come over and they're like, how do I fit that in a numeric response box? And I'm like, well, it asked for the term number. And everyone's like, yeah, I know. How do I fit that in a numeric response box? Well, the answer is 6, not that, right? We're going back into grade 10 for a second. Straight foot speech. All right. We enter grade 10 at least once a day. That's where we go. That's how we roll. All right. So if we have x to the 3 times x to the 2, what would your answer be? X to the 5. Okay, cool. What if I give you x to the 3, 4 minus k? What would we get? X to the 12 minus 3k. Because you have to remember to distribute through it, right? The whole thing. Okay. If I talk to you about a constant term is a term without a what? Variable. Someone whispered it. You were correct. A constant is a term without a variable. Okay? So, if I gave you this, x to the 0 is what? 1. Is x to the 0 technically a constant? Yeah, because x to the 0 turns to a 1. And does a 1 have a variable? No, so it is actually a constant, correct? So, if I gave you x to the 3 times x to the negative 3, what would you get? X to the what? 0. Because what are you doing with your exponents? Adding them. And so you would get a constant, wouldn't you? Okay. If I give you x to the 4 times x to the k equals x to the 0, what would k have to be? Negative 4. Because 4 plus negative 4 is 0. We agree? So we could show this by 4 plus k would have to equal 0, right? So k would have to equal negative 4. Technically, if we solved it out, we could show it that way. Okay, grade 10. Still. 1 over x squared. How else can I write that? We were taught that you can move it to the numerator by doing what? Raising it to a negative exponent. So I can bring this up and make it join the 1, and it become x to the negative 2. Those are actually the same. Okay? What if I had 1 over 3x squared? You don't take the 3, you just take the x up, right? And it would become x squared over 3. Or I could write that as 1/3 x squared. Same thing. Okay? That dog give me the looks. No one's commenting. No one's saying, hey, Lepp, you don't have a negative 2. No, you're just all doing this. So I told you. See, those are my giveaways. Your eyes this, and then look at each other like, she messed something up. Did she? Or is it me? That's what you're thinking. It was me. All right. If I see a few people doing it, I know I'm getting something up. All right. So what if I have 1 over x to the negative 4? What could I write that as? Just x to the positive 4, correct? It's the same thing. We agree? All right. So what have we learned? We learned that we can move any variable off the denominator, move it to the numerator. It just goes to the opposite exponent, like positive or negative, right? We also learned to get a constant, we have to have like x to the 4 times x to the negative 4, which gives me x to the 0, which is a constant, right? Because 4 plus negative 4 is 0. Okay, so we're going to our notes. We can pick up our pencils. This one wants the constant term. The constant term is the term without a variable. And in this case, that's an x to the 0. Because x to the 0 equals 1, gets rid of the x. Correct? All right. We currently have a binomial that is 2x plus negative 1 over x squared to the 15. I don't like it like that. I will always move this up so I don't have a fraction, right? So I'm going to get 2x plus negative 1 x to the what? Negative 2 to the 15. So this is my x. That's my y. That's my n. What are the possible k's I could have? 0 to 15, correct? And that's why you get 16 total terms, because it's from 0 to 15, which is actually 16 terms, right? So my possible k's could be 0 to 15. K's could equal 0 to 15. I'm going to put an arrow there. So there are 16 total terms. These are all just fun facts to remind us what we've learned. Okay. Do I know what k is, though? So when I don't know what k is, I just fill in a k and hope that maybe it'll help me out. So I'm going to get tk plus 1 equals 15ck, nck, x, which is 2x, to the n minus k, so 15 minus k. And then y is negative x to the negative 1, x to the negative 2, to the k. Do we agree? We want our variables to go bye-bye, correct? So whenever it says constant term, we want our variables to get out of our lives. So my hint to you is I always do a side box to figure out what k needs to be. So I'm going to do a side box over here to figure out my k. And how I do that is I just pull the x's out. Because I need the x's to multiply and turn into x0, correct? I want them to go away. So I'm only taking the x portion of this. I'm going to take the x and its exponent, and I'm going to take this x and its exponent and pull them over there. I'm not taking the coefficients at all. So I'm going to get x to the 15 minus k times the other x, x to the negative 2 to the k equals x to the 0 is what I want it to do in the end, right? Because if it equals x to the 0, the x's will go away. Do we agree on that? Okay. Did I take the 2? Did I take the negative 1? Did I take the 15ck? No, because I don't care about those right now. I want to figure out what k needs to be so that those two are one is positive 4 or something, and one is negative 4, and they go away. Or one is positive 8, and the other one's negative 8, and they go away. Right? So, let's distribute through. This is a 1. If I distribute it into this, I'm just going to get x to the 15 minus k. And times, if I distribute the negative 2 in, I get x to the negative 2k. And it equals x to the 0. You guys already told me this. When I have two bases and two exponents, what do I do with those exponents? You add them. So I'm going to put this side together. So I'm going to get x to the 15 minus k plus negative 2k equals x to the 0. Like terms. So I get x to the 15 minus k plus a negative 2k is minus 3k equals x to the 0. So what do I want essentially? If this is x to this exponent and this is x to this exponent, I want those exponents to equal. So I want 15 minus 3k to technically equal 0. Do we agree? So what does k have to be in order for that to happen? 5. Could you solve it out? Could you subtract the 15 and divide by negative 3 and get 5? Yeah. Or could you look at here and say, oh, I need this to be negative 15. So k equals 5. Now say you messed up. Say you got the wrong k. You'll find out when you go to fill it into here and the x's don't cancel off. Right? Go back, try again. So we're going to go t 5 plus 1, because that's what we think k is, based on our mathematics over here, equals 15c5 2x to the 15 minus 5, negative 1, x to the negative 2 to the 5. So we have to remember to also distribute our exponents through as well. So we get T6, 15C5 is what? And then we get 15 minus 5 is 10. And we have to remember to distribute the 10 to the 2 and to the x, the 5 to the negative 1 and the negative 2. What do you think is going to happen if you forget to distribute those? Do you think the answer will be on the test? Are you forgetting to distribute those? Yes, because that's common error. Correct? Your three other answers aren't just like 10x5 and then your other ones are pig, chiclet, and watermelon. Like they're not like three, like, oh, they're obviously not these. That's not how it's going to happen. There are going to be three common errors. So if you don't catch your common error and you continually make the common error, you will feel confident in your answer because it will be there, but it will be wrong. So we want to make sure we do not fall. So if you're someone who's like, I'm not going to remember to distribute that 10 through and that 5 through, you leave yourself a star, star, star. Remember, remember, remember. Highlight, highlight. So you go back and remember that. It's a huge thing for you. You know that's what you're going to make a mistake on, right? These are your notes. Write stuff for you. 2 to the 10 is how much? 24. X to the 10. Negative 1 to the 5 is negative 1. And luckily, negative 1 to the 5 is negative 1. So if you forget to distribute it, it's okay. On the diploma, they'll often make it be to an even exponent, like a 4. Because if you forget to distribute a negative 1 to the 4, you will not get a positive. You'll get a negative, and that answer will be there. And they'll know. I'll know exactly where you made the error if that negative sign is still there. Oh, you didn't distribute the 4, right? This one, if you forget to distribute it, you luck out. Because negative 1 to the 5 is negative 1. X to the negative 10. Now what happens with x to the 10 and x to the negative 10? They cancel. Now why is that? I'm going to show you something. X to the 10 times that 10, and I wrote a 6. Anyone scared for me right now? Because I am a little. Okay. X to the 10 times x to the negative 10. X to the negative 10 is the same as what? X to the 10 times 1 over x to the 10, correct? You have a 10 in the numerator and an x 10 in the denominator, they can cancel. Do you agree? So that's why they cancel off as well. Like physically can cancel. But x to the 10 times x to the negative 10, also you add exponents, so you could look at it this way as well, which is x to the 0, which is 1. Right? Either way, they cancel off. Whichever way that you see that they cancel off, good enough for me. I don't care which one you see. They're both correct. Okay. So then we do 3003 times 1024 times negative 1, and T6 equals what?
Negative 3,075,072.
And the x's are gone, right? Which makes this a constant. So there's my answer. What if I asked for the term number of the constant? What would your answer be? It'd be 6. Term 6. Yeah? Okay, we're going to flip ahead and we're going to actually, I'm going to let you guys do this one and we're going to go do it together after it. You guys are trying 7. 6 will do, but we're going to, the next question is how you do 6. So we're skipping here. So you can leave a little space for 6 if you don't want to. In your homework, leave space for 6 and then do 7. Like I said, though, if it's 7 then 6, I can figure that out. Okay. So we're working on the constant term and then the term independent of x, which means the constant term. So you're trying those two out. All right, every question I've given you so far, I have asked for the answer. I have asked for the term number, 7, 5, 3, 9, 8, whatever it may be. 2, 9, whatever the term number, or I ask for the term. So you give me the answer, like 1024x squared y5, right? I've always asked for the answer, yeah? The last outcome I can ask for in terms and cons and binomial theorem, which binomial theorem is what we're doing right now. It's called the binomial theorem because it's a theorem that you work with a binomial on, right? Binomial theorem acts quite well. Sometimes it's like Pythagorean theorem. Okay, well that's some guy named it after. A binomial theorem is a binomial. If you see binomial, you need to expand it and use the binomial theorem. Right? Well named. Okay. Example 8 and 9 are a little different because in the past I gave you the whole binomial. You had to solve for k, figure out what k is, and then you give me an answer, correct? But for 8 and 9, I'm actually giving you the answer and we're missing part of the binomial. Okay? So, let's see what we have here. One term in the expansion of x plus a to the 10 is this. That is the actual answer. They gave us the answer this time instead of asking for it, right? What is the value of a? So let's fill in what we do know. We know this is x. We know this is y. We know this is n. Okay? So we have x is equal to x, y is equal to a, n is equal to 10, and then k, we need to figure out what the heck it is. When we don't know what k is, we fill in a k, right? And then we can probably figure it out. That's what we figured out this whole time. We can figure out what k is, but sometimes we have to fill it in as k first. So let's do that. So we get 10 c k, x is x to the 10 minus k, y, which is a to the k. And the reason why I didn't put tk plus 1 this time is because I know what the answer equals, right? So this work I have here should equal what? This is the answer. Correct? It should equal 3,281,250 x to the 4. We agree? That answer hints to us what k should be. Does anyone know what k should be by looking at that answer? 6. Why? Someone said that. Who said it? I heard a 6 whispered. It is correct. Yeah. Yeah, so we need the 10 minus the 6 to get us that 4, right? Because we need the x to the 4. Yes? We have an x to the 4 here. I'm going to need an x to the 4 here. So if I know this needs to be an x to the 4, then my k needs to be 6. So this is going to have to be 6, right? Which means that this k is also 6, which means this k is also 6. Do we agree? What's 10c6? A number. 210? 210 x to the 4 a to the 6 equals 3,281,250 x to the 4. Then I can divide by the x to 210 and the x to the 4. So I'm trying to get the a by itself. The x to the 4 is just completely cancel off, and the 210 does. So I'm left with a to the 6 equals, what it was, 15,000, 16,000.
15,600.
Oh, that was right. Okay, pencils down. Going back to grade 10. That's where we like to frequent. Okay, in grade 10, we learned this. Do you see how I'm saying grade 10 all the time is important to us? We use it a lot. Everyone put your pencils down. I need you to understand this. In grade 10, you were taught, okay, well, you weren't given an A because that would have been mind-blowing. You'd be like, what's an A? And you would have freaked out and panicked. So your teacher gave you X's the whole time so that the panic would reduce. So instead of an A, let's do an X. X squared equals 4. Let's say they gave that to you. And then you did what to solve for X? Square root it. You were taught that. But whenever you physically do this with your own hand, like you see how I'm physically making this a root. You see that? What do I have to remember to do? Yeah, plus or minus. Every time. So we get x equals plus or minus 2. Do we know why? Yep.
Because negative 3 times negative 3 is also positive 4.
Yep, because they both result in a positive 4, right? If I work them backwards to solve this, 2 squared is 4, but negative 2 squared is also 4. Exactly true. Same thing works with 4th roots, 6th roots, 8th roots, any of the even roots. If I have the 4th root of 16, let's say, that can be negative 2 times negative 2 times negative 2 times negative 2, which gets me 16, or 2 times 2 times 2 times 2, which gets me 16. So that's why whenever you take the square root, the 4th root, the 6th root, the 8th root, and even root, you always get a plus or minus in front. Make sense? Odds, you do not do that for. Because I cannot take the square root of negative 4. This is not real. It's actually an imaginary number. We don't talk about those in Alberta until you're in university. But let's look at this. What if I give you the cube root of 27. You know what I'm saying without saying it, right? Yeah. Okay, what's the cube root of 27? It's 3. Because the cube root of 27 is actually the cube root of 3 times 3 times 3. It's a 3 for 1 special, so I get 3. The cube root of negative 27 is what? Negative 3 times negative 3 times negative 3, which is negative 3. So you can actually 3, 5, 7, 9, 11 indexes. Those numbers, the odd index, the index is a little number on your root symbol. It's called an index. If it's odd, you can take negatives and you can take positives because they need an odd number of each to be able to pull them out, right? So if it's a cube root, you need 3 of them, 3 of the same thing to take it out. If there's 5, you need 5 of the same thing to take it out. Well, you can get 5 negatives and take out 1, right? Okay, so let's go back to this one. We're going to take the 6th root. And we take the 6th root, it's plus minus. But it's only when you physically take the root. If the root is there, you don't feel like, oh, they forgot the plus or minus. No, they didn't. If the question is the square root of x plus 3, don't put plus or minus in front of it. You only put plus or minus in front of it if you physically take the root yourself with your own pen, with your own pencil mark. Okay? And to get the 6th root, remember you go 6, math, number 5. You pick number 5 because number 5 is the square root symbol with an x in the index. So whatever number you pick first goes in that index. So 6, math, number 5. And what do we get? Plus or minus 5, I believe, right?
Yeah.
You guys try 9. This one was easier than the last one because it gave 11th term, which means k equals what? 10. And then our x, our y, and our n. So k equals 10, x equals ax, y equals y, and n equals 13. I'm very curious if you made the oopsie. Let's see. Okay. So we get 13C10. If you made the oopsie, you should be star highlighting. You'll find out if you make the oopsies you want. So we get 13C10, ax to the 13 minus 10, y to the 10 equals 2,288 x cubed y10. They didn't need to give us 11th term because they gave us y10 and x cubed. We could have figured that out. Correct? That was nice. 13C10 is how much? Thank you. And then this is where the oopsie lies. Let's see if you did it. 13 minus 10 is 3. And that 3 has to go where? To the a and the x. If you didn't, you will make that mistake. We just found out that that is what your brain will do. So distribute. So we're going to get a cubed, x cubed, y10. Your answer will be 8, which is wrong. If you didn't do that. So we're going to divide by 286, x cubed y10. So you get a cubed equals 8. If you forgot the cubed, your answer will be 8. Do you think the answer will be there? That's 8? It will. Do we want you to pick that one? No. People are like, it's trickery. No, it's not trickery. It's just giving you an answer that's possible. If you do everything right, it doesn't matter what my 3 other answers are, correct? You're going to take the right answer. I'm not trying to trick you. It's not at all what we're trying to do here. I'm trying to give you the basis to say, hey, this is going to be the common error. Hey, you fell for it? Cool. It's notes. Who cares? But you need to make yourself a little star, highlighter. Don't forget to distribute into that coefficient every time. Even if that coefficient is a variable, it's still a coefficient. We agree? Now, can we check these if we really want to? Yes, we could go find the 11th term. We could put 2 in for, we could just do this exact part here. See this part here? Instead of having the A, we could put the 2 in there, and we should get this term back. If we don't, we messed up, and that would maybe be where you catch yourself that 8 wasn't actually the answer. Right? Okay, the homework on the next page is all homework. We did most of it. We worked on a lot of it, but so 1 to 10 is due. We have 1 to 4 was due the other day. Now the rest. Up to here.